All right, welcome to your second video on the second lesson for Module 3 for Algebra 3 Trig. And here, what we're going to do is we're going to take an exponential equation and write it in logarithmic form. Again, the key here is understanding that they share a base, meaning my base on my logarithm is going to be this number. This will be log base 5. This will be log base 8. This will be log base 3. This will be log base 12. This will be log. This will be log base 16. So let's take a look at how this works. Again, we're going to write down log base 5. So make that a subscript, like in chemistry when you're talking about how many hydrogen atoms you have. It's a subscript. And then what you do is you just switch these two things, right? The answer becomes what we're evaluating. So the 25, the answer to the exponential goes inside, and then it equals the exponent. So that would be 2. This one would be log base 8. Right? And then again, we're switching these two things. So we would put 1 on the inside, and that will equal to 0. In fact, one thing that's really important to know, this is actually I'm going to star this problem, is that log base anything of 1 is always 0. Always. ln of 1, log of 1, log base 2 of 1, the answer is always 0 because you're always raising something to the 0 power to get 1. Remember, this is the exponent over here. So if this is the exponent, how did we get 1? We raised it to the 0 power. All right, let's just keep going with this. So these two would switch, right? I'll just draw these arrows so we can understand it. These two would switch. These two would switch. So this would be, again, log base 3. That always is going to be the same. And then I do of 1/81st is equal to -4. So the exponent that gave me this fraction is a negative. It's important to remember that negatives in the world of exponents are actually fractions, both for logarithms and exponents. So here we would have log base 12. And here we would do 2√3. And over here we would do 1/2. Please keep in mind that this problem is actually the square root of 12. And if you simplified that, you would get 2√3. Using a factor tree. So going back to geometry, if you wonder, like, how did he get this answer? Because I did this, and so I would get 2 square root of 3 from geometry and algebra 2. So keep in mind that 1/2 is really the square root. Remember that fractions in the world of exponents are radicals, and again, answers to that are fractions are actually negatives. All right, so here we have another one right here. This one would just be log. We would not write down log base 10 of 1/10 is equal to -1. The exponent that made 1/10 is -1. This one would be log base 16 of 8 is equal to 3/4. To help you remember what that means from last time, again, if you've not done your exponential classwork homework, some of the things I'm explaining with exponents, you need to do those. Because what this is actually meaning is take the 4th root of 16 and then raise that to 3. And if you want to know how you get 8, the 4th root of 16 is 2. And of course, 2 to the 3rd power is 8. Okay, so let's take a look at these problems. These are ln's. Why are they ln's? Because our base is, of course, e, right, for both of these. And so what we would do here is we would say log e, but log e is not a thing, so we write down ln. So then we just switch these things. Right, we just switch these around. Again, we're just trying to getting you used to equations. So again, there is no log e, that's actually ln. So log of 50 evidently equals x in that equation. And this one would be ln of x is equal to 0.5. So that's writing exponentials into logarithms. And this is an important skill because of what is happening here. So you might be saying, what do these things equal? By the way, a couple quick typos. This one is not wrong. It's just a little difficult to begin with. So we're going to put a 4 there. That'll make that problem a little easier to understand. And this P is just a typo. We must accidentally click that as we were typing up the notes. So these questions are actually similar to things like this. Like in math, if I had a problem that was like, hey, what is 4/12ths? You would immediately know that that's a third, right? In math, if I have the square root of 25, you immediately know that's 5. Believe it or not, as you learn how to do this, you're going to know that this answer is 2, and this answer is 7. and this answer is -3, and this answer is 1/2. How in the world am I getting these numbers? What do they mean? Well, let's talk about it, okay? So when I look at this problem, what I want to do is I want to remember that this base is the base that I want to have for this number. So this number, I want this base in here. And what happens is this will become log base 6. I don't change the base ever, but I can rewrite this number as a base of 6, so it's actually 6 squared. And what happens is, if you watched my previous video and I told you that log and exponentials are inverses, this is an exponential inside of a log. This is like having, in algebra, it's like having the square root of x squared. That comes out to x because the square root and the square are inverses. Another example of that is simply like if I had 3x is equal to 9, I would use the inverse of dividing by 3 to cancel this out to get the answer for the equation. So log base 6 and base 6, they cancel and they give me 2. Okay, so over here, if I have log base 2 and I need to know what 128 is, it's 2 to something. So I actually did that. I didn't know off the top of my head, right? I had to go to a calculator and type in, is it 2 to the 5th? Is it 2 to the 6th? And then I experimented until I got that it was 2 to the 7th. 2 to the 7th is 128. Log base 2 will cancel with base 2, giving me the answer of 7. Over here, this is again log base 10. A missing base on a logarithm is log base 10. And this would be, keep in mind that 1/100th is actually the same thing as, like in science class, that would be 0.01, right? 1/100th. And so maybe it's easier to understand that that's 10 to the -2. You might get it this way because, you square it and put it on the bottom, or do it that way. The main thing here is these cancel. So I get -2 as my answer. For this one, this is why I changed this to a 4, because it's a little easier to grasp that way. This would be log base 16. And then over here, we would want to write 4 as a 16. You might be like, what? Well, let me ask you, how do I turn 16 into 4? The square root of 16 is 4, but in the world of exponents, that would be a half, right? So remember that a root in exponents and logarithms is a fraction. Cancel out your bases, you get 1/2. So we just keep going with that concept. Here, this would be log base 3. The question is, how is 1/27th a 3? Well, it's negative because it's on the bottom. Remember, negative exponents mean denominators, and 3 to the 3rd power is 27. So these would cancel out, giving me, oops, I'm trying to cross that out. I'm not quite doing it. Let me try one more time. So that would give me -3. And then here I have log base 8 of 1. And you might remember this problem, very similar. I think it's the same numbers. How in the world can you get a base of 8 equal to 1? That would be 0. And so remember that if you have a 1 in the world of logarithms, you're raising it to the 0 power. The last two are a little easier because they're log base e. And so the answer for these problems is actually the exponent. There is a little 1 right there. And ln and e cancel. So this would come out to 1. And then same thing here. Ln and e cancel. That would come out to 2. So just to dial that back to make sure you understand why, ln means log base e. So this would be log base e, e to the 1, to make it look just like the other ones, right? And then we would cancel this. And the same thing here. This would be log base e, e squared. Again, we would never write down log base e, but obviously as we're learning it, it might help you understand why the answer here is 2. All right, so that's that video. Please make sure that you look it over, maybe watch it before you do your classwork. Doing your classwork is essential to doing well on your formatives. Thanks a lot. I hope this video was helpful.